Tell us a little bit about that. What's involved, and why will it take a few years to happen?
There's the concept of discovery, which is really actually a very powerful one. And that means if you're operating with a client like a browser or a laptop or a handheld device, and you've just got 9999 as the DNS resolver. So that's unencrypted UDP. You're connecting, you get it as DHCP, you start to connect, you do DNS queries. That's observable and it's untrusted. So what discovery does, the first step is that it actually allows you to migrate from an unencrypted connection to Quad 9, and it allows you to move up to an encrypted connection. So that's the first step. Essentially, you do a special lookup to a special name, and the resolver responds back and says, here's how you should actually upgrade to encryption for me. And then the certificate exchange happens. And now your client, completely invisibly to the end user, is encrypted using encrypted DNS. So that's great. So that's discovery. Now,
Right.
what that typically bigger recursive resolvers operate on what's called Anycast. We announce the same address from 260 locations around the world. And that means you get routed to the nearest one. And that's the only place you can go. If you're in Frankfurt, you go to the Frankfurt one. If you're in London, you go to the London one. But that's not actually true. A lot of our clients are in China and they get sent to Amsterdam because that's the way
Mhm.
the internet has routed them, even though it's a terrible decision. What we would like to be able to do is say, okay, if you're in China and you're getting routed to Amsterdam, you know what? Instead of connecting to the Amsterdam location, we'd rather you connect to the Tokyo location because it's actually less latency. There's no way to do that right now. I shouldn't say that. There's no easy and reliable way to do that right now. The draft that I'm working on called EDSR does it allows the recursive resolver to say, hey, you've connected to me. We've got an encrypted connection going, and that's great. But you know what? I'm not the best place for you to talk, Mr. Client.
Mhm.
You should talk to this other system, this Unicast system. It's somewhere else. It's a way of using Anycast as a rendezvous protocol, but
Right.
actually ending up and pointing the client to a different place based on latency or based on maintenance mode or based on traffic volume or any number of other different criteria. It allows you to redirect the clients to spread things out. The goal here is actually to put Quad 9 out of business. The problem right now is in order to start a global Anycast resolver, even just to start a regional Anycast resolver, or even an ISP resolver, you've got to have a lot of resources. You've got to be able to take hotspot traffic. You've
Right.
got to be able to handle weird routing issues that send all of your clients to some place where you weren't expecting them to be. And that is a real difficult problem to solve. And it means that you have to have a certain amount of sophistication to operate a medium or large recursive resolver. And that closes the door on a lot of smaller organizations. People are outsourcing their DNS to, Quad 9, or they're outsourcing it to Google or Cloudflare. I would like to see that barrier brought down and simply say, okay, with this technology, you can have a rendezvous server that gets the first requests, but then distribute that out across your network. If you're a small ISP, you want to have people ending up in the city in which they're connected, right? If you have like 5 cities, you want to have your users tend to end up in the 5, in whatever place is closest or best for them. You want to have the ability to have maintenance without having to actually close connections and force a city down and then use BGP to redirect people, which is really ugly and interrupting traffic and everything else. So it's a way to operationalize DNS in a way that hasn't been done before and balance it out a little bit better at the application layer rather than at the network layer.
That is really cool. So you've actually given me